Let's start with the simplest example of all. How to keep a house comfortable inside. Comfortable home environment for a family living in a home in Canada. With outside variable, cold air changing, wind changing, humidity level, ice, sun rays coming in, day out, pressure, snow, and so on. This house and the processes within exist within this outside environment. Within the house, there are many variables, some controllable, some less controllable, that impact the comfort level. You take a shower, there's more water in the air. You cook, same thing. You sleep at night, nobody moves, things dry up a little bit. Hot air is produced by the furnace, of course, taking in energy as a source of energy, fossil fuel. Humidify air is also a process. Exchange air takes in good fresh air, cold air typically from outside, pushes out the bad air, hot. So you have to eat it again. Essentially, what do you control? What's the goal? Let's look at the overall process. 3 processes within an internal environment that exists within an external environment and from which you get feedback. Zoom in. Input, output. Input, output. And the 3 processes clearly interact to create comfort, which is a customer perception. And different customer will perceive it differently. This is a typical Canadian home where you got a furnace, you've got the fans that push air outside, pulls it inside, a humidifier that puts in the water. And what do you control? Well, for process control, you've got a number of inputs. You control the temperature, you control the humidity setting, the air exchanger, and you get some inputs of information. Temperature in, out, humidity level in, out, air pressure, and a trend. This is the last 12-hour trend that you get there, and maybe some forecast. Feedback allows you to detect a change in the process, compared to a standard, and correct. And learned. Every time you do that, you learn as well. Feed forward is when you anticipate, forecast some changes, and knowing your system and how it will react, you change some values in advance. You feed forward the information. Inside, of course, those things are happening at the same time with more or less control. Less than more, actually. And as you take actions, and you clean your clothes, wash, dry, showers, start feeling bad, start taking corrective action. But then, in the next few seconds, nothing happens, of course. It takes a while. There's a lag. So if you don't wait long enough and you go again, I'm still uncomfortable, I change my setting again, then you are building, over-correcting, and you will get a burst at some point that will keep coming much longer than you would like. So building in the lag factor is extremely important in order not to overcorrect, leading to the proverbial boom and bust that we see in so many environments. This is the process control, feedback and control loop. Here that you do not see is a learning loop. Every time you go here, you make some changes, notice some effect. Oh, this is what I gotta do when I see these values. It works. Or this is what I should not do because it doesn't work. The learning loop is right here. Assuming that you measure correctly and that the data is fed to you in time and that you understand the lead and lag of all those variables.